sound right, boys. Sound right, boys. It sound right, boy.
Boa noite, galera! Salve, salve! Bem-vindo a todos e todas para mais uma edição do Zup Open Talks. Hoje vai ser uma edição diferente, a gente vai ter uma edição do Zup Open Talks em inglês, com convidado para lá de especial. Vou me apresentar, sou o Joamar Silva, sou Head de Developer Relations da Zup. Sou um homem branco, de óculos, barba, com fios mais brancos do que eu gostaria que estivessem. Estou usando um boné com o logotipo da Zup, que é o logotipo que está aqui atrás de mim, num fundo preto. Bem-vindos todos ao nosso Zup Open Talks, recados básicos e rápidos. Primeiro deles, a gente tem vagas, então quem quiser vir trabalhar numa empresa onde o desenvolvimento e o crescimento das pessoas é fundamental e a gente acredita que só se faz tecnologia de ponta com gente de ponta, vem para cá que a gente está pronto para receber todos vocês. A galera vai colocar aí, e está na descrição, aliás, o link para as vagas da Zup. E o segundo recadinho importante do dia, semana que vem nós vamos estar no TDC, The Developers Conference, edição online, totalmente gratuita, a trilha da Zup. A gente vai falar de segurança, vai falar de mobile, vai falar de CI/CD, vai falar de desenvolvimento seguro, vai falar de automação, muita coisa legal. Para quem gosta do assunto Developer Relations, a gente está convidando profissionais que trabalham com isso no Brasil para fazer um painel lá dentro para discutir o assunto. Então, tem dúvidas? Que diabo é Developer Relations? O que é isso que a Zup faz e que um monte de empresa de Big Techs faz? A gente vai estar lá, vai ter gente do Google vindo falar com a gente sobre isso. Então, vai ser muito legal, a trilha de segurança está sensacional, só gente muito boa de segurança, e é evidente, vamos falar dos nossos projetos open source. Se você quer conhecer os projetos e ainda não conhece, opensource.zup.com.br. Vou chavear para inglês agora e chamar o nosso convidado. I would like to come on stage, Iván. So, thank you so much, Iván, for being here with us. Iván is one of the key committers on the Micronaut, and since Micronaut is one of the softwares that we use on our development stack here at Zup, this is why we invited you. And no one, I think, better than the people that write the code of Micronaut to talk more about Micronaut, to show Micronaut to us, and to show everything working. So Iván is speaking right from Madrid. So thank you so much. I know that people are probably watching after the event, but it's 6 p.m. in Brazil. In Madrid, it's around 10 p.m. 10 p.m. So thank you so much for being with us on this evening. And the floor is yours, Iván.
Thank you very much for having me today. It's a pleasure to give a talk. So yeah, it's amazing to be able to share what we've done and all the things you can do with Micronaut. So yeah, if we can get started with my slides, thank you very much. So basically, in this talk, what I'm going to show you is all the things. So in like 40-45 minutes, a lot of things that you can do with Micronaut, and I'm going to show you in a practical way. Before I start, let me introduce myself very quickly. I'm Iván López, Ilomar on Twitter. I'm, as we said, I'm from Madrid in Spain, and I work at Object Computing. OCI is the company behind both Grails and Micronaut frameworks. I've worked a lot with Grails in the past, and now I'm core developer of Micronaut. And I'm also running the Madrid Groovy user group. We are the most active and bigger Groovy user group in the world. And it's not a joke. We have more than like 7 or 8 years of recorded talks. So if you learn a little bit, if you know a little bit about Spanish, take a look at our webpage. We have a lot of content there. And then basically that's all, because you are here to learn about Micronaut. So what I'm going to do is I'm going to try to explain what is Micronaut in like 2 slides, and then I'm going to show you the things we can do or you can do with Micronaut. So Micronaut was created from scratch with not only microservices in mind, but focus on microservices. It's a new framework for the JVM. And one of the things, so the creator of Micronaut is Graham Roche. He also created Grails like 12, 13 years ago. So with all the experience he gained evolving and maintaining Grails is built on, or if you don't know Grails is built on top of Spring Boot, but you can use, or it's built also with Groovy as a programming language. So with all the experience, he wanted to build something new, ultra lightweight, reactive. Micronaut is native-based, although you don't need to use reactive programming if you don't want. We also support Servlet, Tomcat, Yeti, and the Toe. And for you as a developer, you can use any of the 3 main languages for the JVM, Java, Groovy, or Kotlin, to develop your Micronaut applications. And one of the key features about Micronaut is this ahead of time compilation. So this means that, for example, other annotation-based frameworks in the JVM, like for example, Spring or Microprofile, what they do, it's amazing what they do. But what they do is when you start, for example, your Spring application, the framework needs to analyze all your bytecode and look for annotation, like you annotate with address controller, you have enable auto configuration, you have all these annotations that the framework understands, right? And the framework does that at runtime when you start your application. So this means that when you have a Hello World application, every application starts really fast. But when you have a real world application with more and more code, what happens is that the framework needs to read and parse and understand more and more bytecode, right? To really understand how your application works when you are doing dependency injections and things like that. And also, the framework needs to cache all that information into memory, which means that with again, a real-world application, it takes more and more memory. On the other side, what we do in Micronaut is the same, but at compile time. So when you compile your Micronaut application, the framework generates some classes, some kind of companion classes. We never modify your bytecode. We never touch your classes. We create another classes with all the meta information that the framework needs for understand your application. In this way, when you start a Micronaut application, the framework doesn't need to do pretty much anything at runtime because everything has been pre-computed. So it's just reading a few things, resolve the configuration, and start your application. With this approach, the framework starts really fast, and the memory footprint is really, really small. We also don't use any of the traditional techniques that other frameworks and libraries do on the JVM. There is no reflection in Micronaut, no runtime proxies, no dynamic class loading, no dynamic bytecode generation, because all these techniques has a lot of performance penalty, either on the CPU usage and or memory consumption, right? So as I said, Micronaut application starts really, really fast. We have a low memory footprint, and we like to use this thing called natively cloud native, which means that if you are developing applications in 2021, you want that the framework provides you a lot of stuff, right? You don't want to create everything from scratch. You want to focus on solving your problem. This means that Micronaut provides a discovery client, externalized configuration, HTTP clients with fallbacks, with retries, distributed tracing, integration with a lot of third parties. You can deploy also to different cloud providers. We have support for serverless because Micronaut fits really, really well in this serverless approach for AWS, for Google Cloud Functions, for Azure. We also have this toolkit called Micronaut Data, which is a database access toolkit. If you are a Spring developer, you probably know Spring Data. And you know that with Spring Data, you declare an interface, and the framework implements that interface for you for access to the database. So if you have a user table and you create a method on that interface called find by name, the framework will implement a query something like select the star from user where name equals full, right? The problem is that is done again at runtime. With Micronaut Data, we pre-compute all the queries, all the SQL queries, everything is pre-computed ahead of time, and all those queries are generated. So this means that at runtime, the only thing that the framework needs to do is getting the pre-computed query, which is already there in the bytecode, do the parameter binding, and execute the query, which is really, really fast. We, of course, have support for GraalVM native images. I will show you this in the demo. And we've been having support for GraalVM out of the box for you since the very beginning of Micronaut. And you will see how it works. Micronaut is open source. It's Apache 2 license, no strings attached. So you can use for anything you want. Since Micronaut 1.0, it was released in October 2018, we have released like about 50 releases. The last stable one is 2.4.0, which was released, I think, last week. And today or tomorrow, we are going to release a next patch version. And we have like around 200 contributors from a lot of places, not only from us. Like, as I said, a lot of amazing contributions have come from the community. So as Linus Torvalds said, talk is cheap, show me the code. So I'm going to switch here desktops, and I'm going to show you all the things that you can do with Micronaut. If you want to create a new Micronaut application, you have two approaches. The easiest one is basically you go to our webpage, launch.micro.io. And in this web page, yeah, it's working now. So you can select the type of application, command line, gRPC, message driven, the version of Java, packages, the different version. You can see now 2.4.1 has been released, the language, the different build tool, and the testing framework. And then you can add any of the features, right? And as you can see, there are ton of features. This is for cache, class, client, cloud. We have for Kubernetes, for Knative, decorate, configuration for database access, yet coherence, data JPA, JDBC, R2DBC, database migration tools, Mongo, MySQL. You can see the list is very long. So you can select a lot of features, and then you click here, you download a zip with everything you need, or you can push directly your code to GitHub if you want, or you can get a command like, so you can do this on the command line if you want. So this is one approach. Another one is you can install our CLI. And with the CLI, what you can do is you can create an application. So this is what I'm going to do. I'm going to create an application. By default, if you don't say anything, Micronaut will create a Java application built with Gradle. And what I'm going to do, because I prefer Spock way over JUnit, which is the default for Java, I'm going to use a Spock for the test, and I want to use JDK 11. So let's open now the application inside our IDE. And let's see the things that you can do. If you are, as I said, if you are a Spring developer, you will feel like at home with Micronaut, because we love this kind of programming model. We've been using Spring a lot in the past with Rails, and we know that it works. So we wanted to make these things easier for Spring developers to use Micronaut. So we are going to create a controller, and as you can see, we annotated with that controller. We define that this is for the root URI, and I want to respond to get, and I'm going to say encrypt, and I need a text. This is public, my message, encrypt, and this will be text, right? So let's create this pollo. I'm going to annotate it with that introspected. I will explain why I need this later in the talk. And I'm going to create just a very simple thing. So empty constructor, getters and setters. If you use, I'm using plain Java. If you use Lombok, you can get rid of this. If you use Kotlin, you don't need this. And if you use Groovy, you don't need this, right? But this is plain Java. I don't want to add more things, so I need this. So I'm going to receive a text, and I'm going to encrypt it. So as I don't have too much time in this talk to do a proper encryption, what I'm going to do is like one thing. My encryption is going to be just reverse the string, right? So this is encrypted, for example. And once we are using Java 11, I can use var, and then just return my message, encrypted, right? So this is my microservice for encryption text, right? You get a text, and I'm going to encrypt it, just reversing the text. So the next thing I want to do, and I want to show you, is how easily you can test Micronaut's application and how fast testing application is. So I'm going to create an encrypt client. You don't need this for testing, but it's useful, and then I will use this later. So I'm going to create an HTTP client. You can see that it will map the same URL of my controller, and it has the same signature with the same parameters, right? So this interface, Micronaut is going to implement this interface at compile time. Again, there is, remember, no runtime proxies, nothing like that, no reflection. So Micronaut will implement this interface for me at compile time, and with this interface, I'm going to be able to access my controller, right? And now that I have this, what I'm going to do is I'm going to write a very simple test to show you how you can do this, because it's really important to be able to test your applications in an easy way. So specification. Of course, you can use, as I said, JUnit. I feel more comfortable with Spock, but everything I'm going to show you here, it works with with JUnit. With this annotation, what we do is we have extensions for JUnit and Spock and cotest. And with this annotation, Micronaut is going to start an embedded server. So and it allows us also to basically inject any dependency we need. So I'm going to inject my client because I will need it for doing this functional test. And the test is going to be pretty simple. Text encrypt controller. And what I'm going to do is when I send this hello world, for example, remember that my controller returns a pollo. So I need to get here the text. And remember that my encryption was something like this, right? Reversed. So this is what I expect. I expect, yeah, I need to select Java 11. Sorry about that. I expect that when I call my client, I get this. I get my text reversed. Of course, the test fails because it always fails the first time. Yeah, I switched a couple of letters. So hello world like this. So IntelliJ here is complaining about something that I don't know why it's in orange. It should be fine. So you see that now the test passed. It took less than 800 milliseconds. And this is a full functional test. We are not bugging anything. In these 800 milliseconds, we are starting an embedded server with the controller. We are and we get an instance of our encryption client, and we are sending an HTTP request, and we are marshalling to JSON and from JSON. So as you probably won't believe me, what I'm going to do, I'm going to duplicate this, and I'm going to my logback file, and I'm going to here enable I'm going to set the HTTP client to trace level because I want to show you all the traffic and all the details that you can see here. So the first thing is that the first test took 800 milliseconds, but the second one only 29. And as you can see, this is the full traffic. Micronaut by default, when you start on the test environment, uses a random port, right? So this is a random port, and you can see sending HTTP request to this localhost encrypt hello world. Application JSON, response received, and this is a response. Application JSON, and you can see here the pollo that we return because we are returning this pollo, and Micronaut is using Jackson to serialize that to JSON. That's why we see here this pollo. This JSON. And as you see, the first one took 800 milliseconds, but the second one only 29. This is because the first time you need to bootstrap the JVM, do the class loading, and that takes more time. But you can see that it was pretty fast to run a functional test. Once you have everything up and running, it's pretty fast to run functional tests with Micronaut. And I'm not saying with this that we shouldn't write unit tests. Unit tests make sense. But sometimes we as developers trade unit tests instead of integration tests because we need to mock a lot of things, or it's complicated to set up everything, or we need to wait 30 seconds until the application context starts and my application is up and running. So we don't want to wait that much time, and we decide to go to the unit test route. But with this approach with Micronaut, you don't need to choose to write a unit test if you don't really need it, right? Let's comment this out. So now that we have this, I don't know why IntelliJ is complaining. So the next step is we don't put. No, sorry. I said that we support reactive programming. So if we replace the signature, I'm going to return an RX Java single, and then here I'm going to say single.just. Right, and I modify my controller. Now this is a reactive non-blocking controller. I need to do the same for my client, and then I need to modify my test. So you can see that this is underlined now because I'm returning a single, and the easiest way to do this for the test is basically blocking, because you don't want to basically subscribe to that single in a test. It doesn't matter if you are blocking. So the test still passed. We are green. It's good. So next thing we don't put our business logic in controllers, right? Because we are not able to test it properly and we are not able to reuse it. So I'm going to show you how you can do dependency injection. I'm going to create encrypt service. And what you need to do is annotate it with a singleton, but it's not working. Give me 1 sec, sorry. I'm going to IntelliJ. Let's try again. I'm going to switch this Java 11. So let's see if it goes, if it works now. Yeah, it's working now. So the only thing I did was moving my business logic to a service, and then on my controller, I'm going to inject it. So private final encrypt service. And here, instead of doing this, I'm just going to call my encrypt service encrypt text, right? So this is dependency injection. Let's run the test again. This is our preferred way to do dependency injection using a constructor, because with this approach, you can define your dependencies as final, which is good. I'm running the application, sorry. You can define your dependencies as final. Everything needs to be instantiated in the constructor, and it's pretty clear what you need to do for your application. We support field injection like I did here with a test, and for a test, it's fine to do at inject, but for production code, please go to this route. It's way better. So you see, I refactor this and the test still pass. So the next thing I'm going to do in this kind of encryption microservice is I want to create more than one instance of my microservice, and I want to be, all these instances will be kind of discoverable. So I'm going to add console as a service discovery. And to do that, I'm going to add, so this is the, I forgot to say, this is the basic build.gradle. If you use Maven, it's pretty much the same, a little bit verbose because you know XML, but we have our own plugin that takes care of everything, and we select the runtime, the test runtime. If I put here, instead of I put in Netty, I put Yeti, Tomcat, or Undertow, we switch to the runtime. The same for test. And the only thing I'm going to do, I'm going to add the console dependency, and then in my application YAML, I need to add the console configuration, right? So you don't need to know about this. If you go to Micronaut launch and create a new application with console, for example, discovery console, which is the thing I'm going to do, this will generate the project. You can preview the project to see how it looks like. And if you click this div button, you will see, basically, as I only added here the discovery console feature, you will see the difference between the plain simple application and the one with discovery console. So basically, this adds this dependency that I already added and this configuration, right, in my application YAML. So you don't need to worry, and you have links in the documentation to go to the docs to see all the things you need to configure. So now that this is running, I'm going to start a console using Docker. And now finally, I think, yeah, last one thing, I'm going to set the port to -1 because I want to be able to start more than one instance in different ports. By default, Micronaut will start on port 8080, but with this, it starts on some random port. So now finally, I'm going to start my application. You can see it starts, and it has been registered in console. It starts on this random port, and now I'm going to start another instance. So allow run in parallel. And with this, I start 2 instances on 2 different random ports, right? So we can go to this console starts on port 8500. And we can see here, we have 2 instances of the script of this encrypt service on 2 different random ports. So we are going to leave this microservice here, and we want to add another thing, because when you have different microservices, imagine that you have a big application with a lot of things talking to each other. you don't want to expose them to the public, right? To your internet, to the internet. You one approach or one pattern that you can use is putting like a gateway. So you put a gateway. This is going to be exposed to the internet, and this gateway talks to every microservice here and orchestrate everything. So I'm going to create now a gateway microservice to talk to this one, to this encryption service that I created here. So let's create another application called gateway, and in this case, I'm already adding by default the discovery console feature because I don't want to add the dependencies manually. Let's open it again in IntelliJ. Let's switch to again. I need to do this because Micronaut still supports Java 8, right? So as I'm developing Micronaut most of my time, I need to use Java 8 to make sure that everything works. That's why I don't have by default configure Java 11 or 15 or 16 in my IDE. So this is going to be my gateway, my public application in front of all my microservices. And I'm going to cheat a little bit because I don't have really time to create a multi-project build. So I'm going to do this and this. So I'm going to create a gateway controller, and I'm going to expose this controller in a different URL. It's going to be API, and then I'm going to do API.version :v1. This means that if I define in configuration in any place in my application YAML via system properties, environment variables, whatever I want, I define API version, that will be used. But if this configuration is not defined, it will use v1 by default. And then I'm going to copy this. And in this case, I'm going to use the encrypt client that I created before, but now it's not going to call this /URI. What it's going to use is this is going to be a client for my encrypt service, and this name is the name of the other application, and this is the name of the so this is the name in which this microservices has been registered in console. So this client will talk to console asking for, okay, what is an instance of encrypt service, and console will say, yeah, you have 2 instances in these 2 IP addresses, and the client will do round robin and call one instance of the other every time. So now I have here this. What I'm going to do is inject my encrypt client, and here instead of using this, I'm going to use my new client, right? So I can probably start my application, this one. You can see that I'm starting the application right from my IDE. It's a public static void main. You can start it from the command line using Gradle or Maven. As I said, we have plugins for both things. And this application, as I didn't configure anything, is running on the default port, 8080. So let's send a request, localhost 8080 API v1 encrypt hello world, right? So you can see this is my text encrypted, and every time I reload the application, my gateway is sending a request to using round robin to every one of these 2 clients or to these microservices that I have here. But we don't have a way to basically check that, right? Because it's the same output. So what I'm going to do, because you shouldn't trust everything I say, I'm going to modify here. I'm going to inject this is embedded server that Micronaut uses under the hood. And I'm going to modify this message to say here like port embedded server get port. And now let's start the app again. So again, 2 microservices. They are starting, they are connecting to console. 49,523 and 28,539. So I'm going to here 49,523 and 28, right? So, and every time I reload the page, we have one port or the other, because by default, you have for free using our Micronaut HTTP client round robin. If you don't like this approach, you can implement your own thing because maybe you want to send all requests to some node because it's closest to your location. You can do whatever you want. At the end, you need to implement a few interfaces, or probably only one, and override a class, and that's all. And you can put here your strategy to do this balancing. But as I said, by default, you have round robin for free. But what happens? So why? Now we have two instances of our encryption service. We have one gateway. But what happens when these instances are down, when they fail? Because when you are creating microservices, you need to be prepared for failure, right? Because services can go down, there can be some network issues, and things can go wrong, and they will probably go wrong, especially in production. So you don't want, if you have here the gateway and a lot of microservices here, you don't want that a failure in this microservice will be propagated through all your system, right? You want to have some kind of fallback to avoid that. The use case for that is, imagine that you have an e-commerce site, you are selling something, and I am a customer and I want to buy a book. And it's common in these places that when you see an item, a book, you have, for example, a recommendation service that says, okay, other customers that bought this book also like these ones, right? So if this microservice, the recommendation microservice fails, you don't want your page to be blank or to fail. You still want to be able to sell that book, right? So we are going to implement, you will implement a fallback that if that recommendation microservice fails, the fallback will return, for example, an empty list, and the UI won't put any recommendation, but at least you will be able to sell the book, which is what you really want, right? So I'm going to implement, I will leave the backend up and running. I'm going to go to the gateway. I'm going to stop it, and I'm going to implement the fallback in 3 steps. The first one is, this is the client we are using. So I'm going to copy this, and I'm going to create here a new interface called encrypt operations. You can call it encrypt API. And this interface will only have the contract I want to make sure that everyone fulfills, right? This is a plain interface, no annotations, just plain Java interface. Now my client can extend my encryption operations. I override it, and in my client, I keep my annotations to make sure that Micronaut knows that this is an HTTP client. And I also need to do here, because I want to provide a fallback, so I need to annotate this with at recoverable, and I want to say, so this is going to be able to recover, to have a fallback for this interface. This is the first step. The second one, which is pretty easy, is that I want to make sure that my controller also implements my interface, right? Because again, I want to have the same constraint for everything. And as you can see, nothing changed. The only thing is that now IntelliJ knows that this has been coming. This is coming from one. This can be final, by the way. This is coming from one interface, and the last step is basically implementing my fallback. So I need to create a new class, encrypt client fallback. The name is not important. You can put anything. And the thing is that you need to annotate it with a fallback, and you need to implement this new interface. And the signature needs to be the same, but here what you are going to return is that fallback. When the microservices, the encrypt service microservices are not available, this is what we are going to return, right? So I'm going to return a single.just, new my message, and here I'm going to say this is my fallback, right? And I think that's all. Let's start the application and see if it works, right? So I haven't changed anything. So my backend is still there. It's working. And what I'm going to do is I'm going to stop both instances of my encryption service and reload this page. So as you can see, immediately we have the fallback. There is no delay. There is no 500, no 502, no 404, nothing. This is a 200 HTTP OK, but I have a fallback, right? So it's not the best case scenario, but at least my request is not failing. I still be able to sell that book that the customer was interested in. Once I start my services again, I can start one, and when it starts, it registers in console, and there you go. One, it's running, and when I start another instance, or maybe 3, I can start more instances. So let's start 3 of them. So you see now 3 different ports, and as I said, we have round robin by default. So with this approach, you can implement in a simple way these kind of fallbacks, which are really helpful. We also have another annotations. There is one called retriable, which you can configure, for example, the delay. So this is useful if the request fails, you may want to delay and retry a little bit in like 500 milliseconds or so. So you can do this with this annotation. And we have another one which is called circuit breaker that implements this pattern of the circuit breaker pattern. And again, it's highly configurable. You can define a lot of things, and these annotations are baked into Micronaut, so you don't need to add a third party and external dependency to do this. They are there for you, and they follow the same approach. No runtime proxies, no reflection, nothing like that. Okay, so I think I have time. So if I had more time for this, one of the things I like to show you, there are 2 things. One is using distributed tracing with Zipkin, and the other one is using persistence with microdata JDBC. But I don't have time to do both of them. So what I'm going to do, I'm going to go to the Zipkin road because I think it's faster. So I'm going to add support in this application to Zipkin. So you need to add dependencies. Again, if you go to our launcher and select here the Zipkin feature for distributed tracing, you can see these dependencies and this configuration I need to add. So again, don't worry about it. I have these shortcuts for me, these live templates for IntelliJ. So I put my dependencies, and then I need to put here my, where is it, my shortcut? My configuration, right? The only thing I changed by default is this. This is so with Zipkin, you are going to send to Zipkin a sample of the request to be able to trace everything. So you don't want to send probably in production all your requests to Zipkin, right? You can say, okay, I want to send like 10% of the request, or 25%, right? So, but this is a demo, and I don't want to send a lot of requests, so I'm going to send all the requests to Zipkin, and that's it. Let me start Zipkin. I have here a Docker container for Zipkin, and I need to do the same changes in my microservices. So this is let's start my gateway. I'm going to stop all 3 of them, and I'm going to do again the same changes here. I'm going to add my dependencies, and I'm going to add here in my configuration the configuration. So let's start one instance. Now we don't need more. Yeah, so nothing has changed. The only thing we did was adding Zipkin and configuring. Zipkin has this nice UI in this port, and whoa, way to zoom. And as you can see, I'm going to send a request. I'm going to say hello Zipkin. So yeah, it works. And if we go to Zipkin, we can find here the microservices, right? Gateway and encryption and console. And here we can try to find the requests. So let me decrease the zoom a little bit. So this is, where is it? Probably this is the one I sent, right? You can see the gateway, get API v1 encrypt text. This is something in the middle, and this my encryption service, right? And you can see the path. And we are tracing everything, and you didn't need to configure basically nothing. Add the dependencies, add the configuration for Zipkin, and that's all. Micronaut will do like best effort to try to figure out what's going on. But if you want to personalize and customize this, you can do more things. So in the gateway controller, let me close everything else. What you can say if, okay, every time I call this endpoint, I want to create a new span. A new span is like, I want to start a new tracing and everything will be included in this kind of tracing. And I also want to say, this is a span tag and I want to call it like plain text. So what this is going to do is now we are going to send this text to Zipkin as meta information, and it will be safe in this variable. So if I go back, where is it? Here, I send hello Zipkin with tracing, whatever, and go back to try to find this request. Probably this one. Yeah, hello Zipkin with tracing. This is the request, but you can see here that now this plain text and the value is the one I put here on my controller. This is useful not to store, if this was a real text that I want to encrypt, you shouldn't do this, right? But it's useful, for example, to put here the user ID, because this header will be sent to every request. And if something fails on production, you want to have something to look for, right? So if you save here, for example, the user ID or the date or something like that, then you can check on the logs on your database or whatever, what happened with that specific user ID, because you store here some kind of meta information with it. So the last thing I'm going to show you is I said at the very beginning that we support GraalVM. GraalVM native images, so basically GraalVM is a new polyglot virtual machine from Oracle Labs. And with a native image, what you do is you convert your Java application to a native binary that will start really, really fast and will use way less memory. So I'm going to switch to the Java, to the GraalVM JDK. So you can see GraalVM Community Edition. This is the latest stable version. And the only thing you need to do, it's if you are running in Gradle, run this task. Gradle W native image. And this is going to do everything for you. I'm going to open here. This is my system monitor. So this native image, it's going to take like around 2 minutes, 2 minutes and a half to create the native image. And you will see here what's going on. I have 6 cores, 12 CPUs, and this process is going to take pretty much all of my CPU, and it's also going to take a lot of memory. So you saw that here there was like 14 gigabytes of RAM used when I started this, and during this process, the memory consumption will go up. It will use around 6 or 7 gigabytes of RAM to build the native image. And at the end of the process, you can see here that my CPU it's pretty used, but at the end of the process, you will see here like a continuous line. All the cores will be like a 100%. So as I said, we support GraalVM since the very beginning. When we released Micronaut 1.0 back in October 2018, we already supported the previous release candidate versions of GraalVM. And in every release of Micronaut, we are improving more and more the GraalVM support for making easier for you users to basically convert your Micronaut application to GraalVM. So you don't need to do anything else. This is the only thing you need to do. Run a task. If you use Gradle, if you use Maven, there is another maybe they are called goals, right? But there is another goal and another packaging that you can select, and it will do the same. Package everything as a native image or create a new native image for you, and you don't need to do anything. We are working with the GraalVM team a lot, and we've worked a lot. We have reported a lot of issues, and we have improving the support for a lot. We have a lot of things that so you can use JDBC, you can use RabbitMQ, MQTT, Netty, Yeti, Tomcat, views, Consul. A lot of things work with GraalVM. You can see now, as I said, everything is like 100%. Now it's going to finish. It's going to put here compile, this is the task that is running now, the compile task. And once it finishes, it's going like to write the native image, and basically finished. This takes a little bit more than expected because I'm sharing the screen with you, and that always takes some additional CPU and memory. So it's going to finish right now. And you will see now, once it finishes, here, my CPU now it's not 100% because this is the highly intensive task. And now you will see that my memory will be back from here to where I started, like, again, my 15 gigabytes of RAM. So after this process, what I have is this file, right? It's a binary, 79 megabytes, but this binary doesn't have any dependency of the JVM. You can start a small Linux Alpine or distroless Docker container, and you can run it inside because it's really small. And as you can see, it starts really fast, 76 milliseconds. And you saw here that the last one I started was like 3 seconds. This is, as I said, this is slow because I'm sharing my screen, but even with that, 66 milliseconds. And the nice thing is that everything works. Port 26590, if I go here and I reload, 26590, right? So you have here your full application package as a native image with 15 support, with Discovery Console, and everything. So let me go back to my slides to basically finish my presentation. So as a summary, you can create with Micronaut as a developer application with Java, Groovy, and Kotlin. You can choose the language you feel more comfortable. We have support for a lot of native cloud stuff. As you saw, I show you today distributed tracing with Zipkin, discovery service with, or service discovery with Consul. We support also, for example, Jagger for distributed tracing. We support Eureka for service discovery. If you deploy to AWS or to Kubernetes, we support those the discovery services that are there. We have a lot of stuff supported. If you are a Java developer, a Spring developer, you will feel like home because the dependency injection and everything is the same. Like it's the same developing mode, and it's like the things that you were doing before. You are used to do things like this. You have services, you have controllers, you do dependency injection. Everything is the same. The key feature of Micronaut is this ahead of time compilation with no reflection or runtime proxies, anything like that. GraalVM does the same. It took like 2-3 minutes because what it does is doing this ahead of time compilation. It's reaching all the code in my Java application and converting that to a static binary. With Micronaut, you have fast startup and low memory consumption and low memory footprint. And if you deploy your app as a GraalVM native image, you saw that the startup was even faster and the memory footprint is really small. And at the end, developers are happy, are productive. They have one other tool that they can use to solve the problem and not fighting the framework. So if you are interested in learning more, that's our Twitter handler, Micronaut Framework, micronaut.io. That's our main page with everything you need to know. There is the documentation, the project. That's the main Micronaut core GitHub repository. If you like it, give us a star. Guides.micronaut.io. This is really important. If you want to do something with Micronaut, we have a lot of guides that show you with an example and a repository that you can clone and run how to do something in like 15-20 minutes. So if you want to learn how to do security with JWT, how to access a database, how to do this console, distributed tracing, how to support render server-side rendering. There are a lot of guides that show you with a lot of examples and with code that you can run how to do something with Micronaut. And the last link is our Gitter channel. Gitter is like a Slack, right? So the development team, we are there. If you have any questions, go there and we will be happy to help you. And yeah, I think that's all. Thank you very much. And if we have questions now, let me open this.
Yeah, Ivan, thank you so much. And I really like when people show code instead of slides. So
Slides, yeah,
thank you
because
so much.
slides always compile, right? And
Yeah,
code not always. You saw that I have some problem with IntelliJ.
yeah. No, it was really amazing. I really like to see live coding and things like that. And sometimes we find some errors or things like that, and it's really great because people can see how to solve things and so on. We have a couple of questions here. The first one is from Camila. She's asking, is there any plans to support NoSQL in Micronaut data?
Yeah, so we have integrations out of microdata for MongoDB, Neo4j, Redis, Cassandra, pretty much everything, but they are not integrated in microdata. But yes, we have plans in our roadmap to add support for MongoDB, DocumentDB, these kind of databases into microdata. I don't know, I don't have a date for that, but it's definitely in our roadmap.
Okay, the other one is from Rodrigo. He's asking, what are the next steps for Micronaut? Features to implement, integrations, that kind of thing.
What? Can you say that again, please?
What are the next steps for Micronaut? The features to implement, the integrations, that kind of thing.
So in every release, we try to release a new minor version of Micronaut every 6-7 weeks. So we will release Micronaut 2.5 like probably by the end of May or something like that. And in every release, we focus in different parts. So we always try to add new features in every version and fix bugs and things like that. So we are trying to kind of balance what we can add new and focus on things that we already have that we, for example, want to improve. One thing we did for Micro 2.4 was improving our AWS staff so AWS, the AWS team published the SDK v2, which has now support out of the box for GraalVM. So we upgraded to that version, and basically what we did was removing a lot of code that we had there for making the integration with AWS things easier. Now we don't need that. It's included in the libraries, but at the end it's easier for users because they don't want to worry about, will this S3 thing or my SNS or DynamoDB or whatever work with Micronaut and AWS and native images? Now the answer is yes. So yeah, we have a public roadmap. If you go to our GitHub repo, the Micronaut core, in the wiki page, there is a public roadmap of the things we are working on and of the things that we have planned for future releases.
Okay, excellent. People who want to send us more questions, this is the time. We have another one here from Rafa. That is, do you think any problem in working with Micronaut in a so not reactive way? Seeing that, just a second, I'm trying.
Yeah, since using like Netty.
Where's the question?
So I don't understand Portuguese, but yeah, it's like pretty much like Spanish. So basically, it's is there any kind of problem working with Micronaut and Netty?
In no reactive way.
In no reactive way.
See that under hood it uses Netty.
Yeah, that's a very good question. So yeah, Netty, it's reactive by default, or it's fully reactive, and it's you shouldn't. Netty has this even loop. So if you use a servlet approach like Tomcat or Yeti, you know that you have like a pool of 70, 80, 100 threads, right? And every thread gets a request and it's blocked until you respond. With Netty, there is a small even loop. Usually it's like 2 times the number of cores you have. So it's really small. And the key thing is that you should never block Netty even loop, right? Because you have only a small number of threads. So if you are doing reactive programming, everything works great. If you are using Netty and not doing reactive programming, which is perfectly fine, you don't always need that complexity. The only thing you need to do is we configure that, we change that in Micronaut 2, but basically you can set a configuration saying that everything will be run into the IO thread pool instead of in Netty thread pool. So once a request comes, we move that to another thread pool, and you can block that request if you want. I mean, you can put their blocking code like access into the database or sending HTTP request. And if you don't want to configure that by default, another approach is annotate your controller. You can put an annotation at execute on your controller, on your method in a controller, and saying I want to execute that on my EAO thread pool. But if you don't do that, it will run on Netty event loop. So you need to take care, basically, unless you configure by default in one way or the other, you need to take care of basically saying, yeah, this code is going to be blocked, so please move, let Micronaut that it needs to be moved to the IO thread pool.
Okay, Rafael sent another one. Which kind of limitations the use of native image brings to development with Micronaut? For example, the using libs or frameworks.
Yeah, so Micronaut, it was pretty easy, I mean, or not complicated, terribly complicated to support GraalVM with Micronaut, because we don't use reflection, we don't use those techniques. That doesn't match really well with GraalVM. GraalVM does this ahead of time compilation as well as Micronaut, so they match really good. So everything in Micronaut works as a native image, but the problem is that, or not the problem, the reality is that when you develop applications, you use third-party libraries, right? You want to use Hibernate to access your database, or you want to use a library to send emails, or whatever you want. And the answer for that basically is it depends. It may work, it may not work. It's like a try and error. We are working with different. So every time we add support for something, we try to submit pull requests to the libraries, because instead of having them configure only for Micronaut, if I send a request, a pull request to, for example, I did for, I think it was for Liquibase or for Flyway for the migrations. If they merge that into their code, everyone using that libraries can benefit of that. It's not only the Micronaut users, it's everyone using Liquibase or Flyway. So sometimes we do that, and sometimes the maintainers of those libraries accept the pull request and they want to have support for GraalVM. Sometimes they don't want, and then we keep our configuration in the framework. But as I said, we have improved a lot the support for GraalVM, and every new version there are more and more things supported. What I should say is that, or if you are using Micronaut with anything and that doesn't work with GraalVM, file us an issue and we can take a look, because maybe it's something that we need to configure and it's pretty easy, or maybe it's a bug on GraalVM. They are evolving the technology, and they add more and more things every time, and they fix things. So if that doesn't work, I've opened a lot of issues to GraalVM with sample projects, and they fix them, right? So if something doesn't work, let us know, and we will figure it out.
This is the magic of open source, right?
Exactly. Yep.
Exactly. So, guys, last minutes to send any other questions while I'm thanking Iván a lot. I know it's pretty late in Madrid right now. It's like 11 and something p.m.
And, don't worry. I usually go to bed around midnight. So
okay. So still have.
And tomorrow it's holiday here in Madrid, actually. So it's Father's Day tomorrow.
And I don't know your situation here, but we are home here in Brazil. We are on quarantine. Mm-hmm. Mostly everything is closed. So if it's a holiday, it's not a holiday. The only thing is
we can go outside, but we prefer to stay at home unless we really
yeah. Here we stay on the computer the whole day. The thing is watching Netflix or coding or working. But anyway, this is what we've been done the past year. So thank you so much, Iván. It was really a pleasure to have you here. Thank you for accepting the invitation. Doors are open. So as soon as you have any other new things to talk about Micronaut, that you want to come virtually to Brazil, I hope we can host you physically here as soon
that would be awesome.
as everything closes. And thank you so much.
Thank you very much for having. If anyone has any questions tomorrow, next week, whatever, ping me on Twitter or go to our GitHub channel, as I said, and we are here to help you. So don't hesitate and contact us. We will help you. Thank you. Thank you very much. Obrigado.
Thank you so much. Obrigado, pessoal. Valeu, galera, que ficou com a gente até agora. Quem tá aí no canal depois, quiser compartilhar, como vocês viram, foi uma aula de Micronaut, live coding, deu para explicar tudo, mostrar como tudo funciona. Ele deixou todos os contatos dele, da equipe de desenvolvimento, do time do projeto, etc. Mais dicas que isso, impossível, beleza? Muito obrigado. Quinta-feira a gente tem outro Zup Open Talks e vai ser especial. Eu não vou dar spoiler do que ainda, a gente vai contar. Segue a gente no Twitter. Não esquece de dar like no canal, dá uma curtida no vídeo aí. E ó, o conteúdo tá aí. Daqui a pouco vai ter subtitle automático do próprio YouTube, para quem não entende tão bem inglês, tá certo? E divulguem pra galera. Quem quiser aprender Micronaut, entender como é que funciona, tá aqui uma aula. Muito obrigado a todo mundo. Uma boa noite. Thank you so much, Ivan. Good night.
Thank you.
And doors are open for you here at Zup.
My pleasure. Bye-bye.
Bye-bye.